Okay, so when I put minus, it's because it's coming down in the Cartesian format. And we know that acceleration at point A is going at minus 7 j feet per second squared. Okay. Yes.
Why is it a positive now? Negative squared are good.
Later on, I will change to minus. Oh, sorry. Now, for this case, it does not matter because later on it will be equal to 0. So this is just the general formula. Okay, I can put into minus also. Okay. Can you change this to minus? Okay. And I'll tell you why is it going to be equal to 0. Okay. So point A and point B are under linear motion only. Okay. So point A and point B are under linear motion. So if you look at point A and point B, this is the motion of point B. And the part that this is coming down also, this is our motion at point A. Okay. So when that's the case, these are for point A's and for point B, right? So A is equal to acceleration is equal to A tangential plus by what? A normal. Okay. But the A normal over here, this is equal to 0. And this is because point A and B are under linear motion only. Okay. So if we expand the term now, okay, so I'm going to expand acceleration of point B is equal to acceleration at point A plus by alpha cross R B from point A minus by omega squared R B from point A, right? So now if I'm going to, or we are going to expand the term, right? In the full blown of the acceleration at each point, you have A of point B tangential plus by A of point B normal is equal to A of point A tangential plus by A of point B normal, then plus by alpha cross R B from A minus by omega squared R B from A. So when writing this, you all of a sudden see this expansion occurring now. We did not have this in velocity, but we have this in acceleration. So this term over here is for point B. This term over here, sorry, this is A, are for point A. And this term over here are for point B relative to point A. Okay. So if I'm going to bring this down further. Sorry, can you give space like what I do? So we know that this is the linear, or this is the tangential, okay? So T is the tangential. Over here is the normal. This is for, again, tangential. And this term is for normal. Now, you only have normal when you have what? Okay, when you only have normal when you have, okay, when this term over here and this term over here, you only have normal acceleration when you have what? Angular what? Angular motion. But when you look at the motion over here, right, at point A and point B, right, for point A and point B, right, what we see is we only have what? Point A only have linear motion, and point B also have what? Linear motion. Now, when we have B relative to point A, that's where we have what? That's where we have our linear and angular motion. Are we clear? Okay. So from here, we have to now find, okay, so looking back at the formula down here, right, we have to now determine what is our omega. Okay, we have to determine what is our omega. Now, just to reflect on what we have, right? So if we look at acceleration at point B, which is a tangential, okay? So we're going to assume that A, B tangential is going in that direction, so it's in I, okay? So we know that over there we have ABI. Again, down here, I'm going to assume going in this direction. Okay. Later on, the vector will help us correct. Okay, when we do the I and J component, it will help us correct if the assumption is right or wrong. Now, we have to use vector form for this. Okay, because sometimes, for this example, you'll see, no doubt the motion is going towards your right, the acceleration can be in the opposite direction. So you have to be very careful over here. Okay. Right, then we have acceleration at point A, tangential, and this we know that is equal to what? Minus 7 what? Minus 7j. Okay, that we know that is equal to minus 7j. Okay. Okay, then the next thing we have to next find omega, or RB from point A. So this is straightforward. So reference point is point A. B is what we want to know. So you will have 10 cos 60 minus by 10 sine 60. Okay. So this will be equal to B A 5I (8.66). Okay. We don't know what is our omega. Okay, so we have to determine omega. Okay, so we're going to determine omega. I'm going to take this whole thing again. Okay, we are going to determine omega using instantaneous method. This is a revision for you guys, right? Okay. So we know that VA is moving down in that direction. We know that VB is going in that direction. Okay, so we know this is coming down. We project a line perpendicular to our velocity. Then we project another line over here. Then we label this where intersect, and this is our instantaneous center. Okay, so we found where our instantaneous center are now. So from here we can find our, so it's going down, we can find what is our omega AIC. Okay, so from here we know that AIC is equal to 10 cos 60 AIC, yeah, is equal to, no, yeah, 10 cos 60. So AIC is equal to 5. Okay. So from here, we know that our omega, so if we write down VA, omega AIC, and this will be multiplied by the distance AIC. So VA is equal to 5. Okay. Omega AIC, and this is also at 5. So omega AIC will be 5 divided by 5 is equal to 1 radian per second. So we also know that omega B IC is also equal to what? 1 radian per second. So if we are curious, we don't actually need this value, but if we are curious, right? Velocity at point B is equal to 1 multiplied by B to IC. So B to IC is equal to B. So this will be equal to 1 multiplied by sine 60, 10 sine 60. Is equal to 8.66 feet per second. Okay, so 10 sine 60. So I'm just going to go through, if we know VB, this is equal to VA cross omega AB no, cross, come on, EJ, plus cross R B from point A. Okay, so this we have 8.66 I V